Good morning, students. Already we have learned about video lectures. That is our first part regarding minimization technique. Before this or before video, we can we can learn about different logic design, different logic concepts regarding logic definition, regarding how to design our Boolean function, how to minimize the Boolean records, what are the different advantages, what are the different disadvantages regarding logic gates, then how we are minimization techniques has been used. What do you mean by the pause method? What do you mean by the SOP method? Just we have taken the review on this. We are not getting exactly what is the details and what is a pause function and what is a soft function and how it is used for the kmap function that we have that still we didn't learn about it before to go for the minimization of the all the techniques. For the minimization of all the boolean functions, we are going to assign these these points that should be the contents which is we have covered in this lecture. That is minimization of a boolean function. Then what are the different operators are there, what are the particular different implementation techniques are there. According to this implementation techniques, which particular gates are used to assign to assign minimization of different values, or we can say that minimization of different variables. Along with that, we have a different Boolean laws with the considering the minimization techniques. So we had to start our video, we had to start our series lecture on one by one according to this. Now we have to proceed for next slide. What do you mean by minimization of your Boolean algebra? How we can cover the algebra. Sorry, it's a Boolean algebra. Who are going to discover the Boolean algebra? That is the mathematician George Boole. So on concept with the Boolean algebra, with the concept with the Boolean functions, it should be developed by our English mathematician, that is George Boole. It should be in between 1815 to 1864. We can say that the George Boole is a scientist which has discovered or developed the Boolean algebra, which is used to minimize all the techniques, which is used to minimize the maximum data of variables within a compatibility output. It is, we can say that it is described as an algebra with your logic. What are the logic? The logic behind true or false. The logic behind logic low, logic high. It is logic behind 0 and 1. The logic behind false and the true. Logic behind yes, it is yes. Then we are getting the output. And the logic behind no, we are not getting that particular statement. But how it will be covered, how it will be defined, how this binary decision has made, along with this all the boolean function, who are going to responsible for all the binary function, who or how we can go for the minimize all the data, how we can cover all the data within our stipulated or within a particular theorem, that we will see in this lecture one by one. Next, we have to proceed for your next slide. Okay, we know that we have a logical operation. This particular logical operations are used for the digital computer. It is a representation of the high voltage assigned by the one. it is represented by the zero, that is considered as a low voltage or the zero voltage. But whenever you go for the fundamentals, when you have the logical operation, when you perform this particular logical operator, what are the fundamental logic operators are there? Being as an engineer, you are coming for your second year. Suppose first year students are getting admission for getting the admission on your 10th basis, or it is the 12th basis. I think ICSE CBSE boards having these are the syllabus in your mathematic, included in your mathematic. Okay, that's our logic operator. What are the logic operators? That is a and operator, we can say that it is a or operator, and the not operator. But what the same synonym or the name we are giving, and as a conjunction or as a disjunction, not is a negation and the complement. These particular terms we are used for the ones complement and the twos complement number. Already in a first video lecture, we have learned about what are the particular complement factors, how we can define this particular complement values, how we can go for the ones complements to the twos complement. That we have taken only review of this. We are not getting exactly how we will follow the complement value, and how the complement value can be used to minimize the data. That is, or we can say that this particular operation or this particular fundamental we had to use to given as a sign value, or we can say that it is used for the your magnitude value. So just we have proceed for the next slide. Okay, this already we have learned about, that is how the number based conversions are there. So we had to proceed for your next, that is and logical operator, how it will be performed. Because when you are consider the operator, minimum two variables are there. That is, it may be the x and y variable. In a sometime we can say that it is a and b variables are there. So according to the these particular two variables are there, we have a different operation. We have different possibilities are there. These particular possibilities, we can say that it should be the combination of 0 0, combination of 0 1, combination of 1 0, or it should be the 1 1. But what will be the output we have to be considered when we go for the and as a logic operator, and how it will be denoted by which sign? That is, it is denoted by your dot sign. That is, we can say that suppose we have a x as a one variable, y is a another variable, and these particular different operators are considering the um, different combinations along with your binary operation from the 0 to 3. We can say that 0, that should be the 0 0, 1, that should be the 0 1, 2, it should be the 1 0, and 3 should be the 1 1. But what will be the output? Because when we can say that as an and logical operator, we have performing the logical multiplication operation is there. Then already we know that when any value will be multiplied with your zero value, the output should be the 0. So that the consideration we can go for the 0 0, the output should be the 0 0 1, output should be the 0 1 0, that is output should be the 0, and for the 1 1, the output should be the 1. But we cannot say that this is a we have the operators are there. They have their particular base radius is there, and have the general equations are there. That is, suppose we can say that we have a input minus whatever the base radix we have to be consider, then it will be given for the your minimization technique. So these all we had to be going for the and as a logical operator. Okay. Next we had proceed for your or logical operator. Okay, logical, it is performing the addition over there, but it is for your concept. It is for your logical thing. But we cannot say that it should be the addition, because when you go for the binary addition, when you go for the binary subtraction, then some other concept will be arising, some other concept will be occur over there. That is, suppose we have a 1 plus 1, or we can add two binary data as a 1 1, then the output addition or binary addition should be the 0 and carry will be the 1. But here actually they are saying that it is a logical addition, but no, we cannot say that it is a logical addition, because we can only say that whenever we have any one logic will be the high, and suppose we are operating the or as a logical operator, then output should be the high. So this particular concept we can apply for the or as a logical operator, but we cannot go for the it is a logical addition. Logical addition is a different concept whenever you go for the binary addition and for the binary subtraction. So we can say that we have a different two variables are there with the combination of 0 0, combination of a 0 1 1 0 and the 1 1. But when you add these all the things, or we can say that we had to be use, or we can go for the operator as a or operator, then we can say that any one input should be the high, then output should be the high. So this is a very clear, crystal clear concepts are there whenever you go for the or logical operator, and whenever you have the operator as should be the in terms of your or values, then one input any one input should be the high, then and then only you are getting the output as a high. Okay. Next proceed for your slide, that is what we can say that as we know that we have a and operator or operator, then third one is a not operator. These are the basic operators we have to be using, and it can be used for the Boolean function, and it can be used for the Boolean laws. It is when you have understand about all these operator things, when you go for the all the operator phenomena, then at that time this particular denoted values, and this particular operator with considering the different functions, then only we can understand our different logical laws. Then we can say that we are operated different functions when when we know about these all the operator values, these all the particular gates, these all the particular operating different variables are there. So when we have the not gate, or the we can say that we have a not operator are there, means it should be the complement the particular variable whatever the input we had to be applied. In this particular things we can say that x is your input, and we have a complemented, that is we can consider y is output, y is equal to x of complement of this particular value. Means complement is what means we have to be apply 0 as an input, then we will get 1 as a output. When we had to be apply 1 as a input, then we will get the 0 as a output. Means the negation and the complement value for whatever the input you had to be applied, it is done by not operator, or it is done by we can say that not logical operator. Okay. Then we had to go for the next slide. That is, we know that we have a different values, we have a different operators, we have that all the truth tables and contains for the all the possible values. But how we can calculate that different variables, how the statements are given for the Boolean expression, then it depends upon the number of possible combinations. So already we have seen that we have a operator that is and operator or operator, these are the having the two input values are there. Then what are the different possible combinations we have to be considered? It 2 raised to n is the number of variables we have used. How many number variables we have used in the and the or operator? That is a 2, means 2 raised to 2, that the combination we had to be considered for this, that is 2 raised to 2, that is a 4. So already we have a 4 different variables or the combinations are there, that is 0 0 0 1 1 0 and the 1 1. These all the possible combinations are only calculated by 2 raised to power of that n variable, and n is nothing but the number of variables used for your Boolean expression. And it is a very important thing when you go for the design any logic circuit. When you go for the design any circuit, we can say that it may be the combinational circuit, it may be logical circuit, it may be in terms of your sequential circuit, it may be design your all operations based on your logic design. This is concept, it should be the Boolean expression. Next slide we had to be go for. Suppose we have taken one example over here. Okay, we have a different variables, that is x, y, and z variables are there, and 0 1 2 3 4 5 6 7, these variables we have counting as a decimal number are there. And we know that we have a different three different variables. So according to the Boolean laws, whatever the different combinations we had to be used for this, that is 2 raised to 3. 2 raised to 3 means total 8 combinations are there, starting from the 0 and ending with your 7. So what are the different variables we had to be used for this? That is from 0 0 0 to 1 1 1. And how we can go for this, and how we can calculate it for this, it is a evaluative operations has been done, that is a and operator along with the or operator are also. For this we have a different variables x and y, and x, y, and z. We have a two combinations which is applied by the and operator, and the x, y plus z, it is a combination of your and operator and the or operator. They have what will be the output we have seen. That is, we know that x and y, what the particular things we have to be considered, it should be 0 0 means output should be the 0. But both of the combination, we can see that, that is for the and operator, we know that any one should be the 0, then output should be the 0. So firstly we had to be find out x and y by the term of your and operator, then output should be, suppose both are the 0, then it should be the 0. Any one of them will be the 0, then output should be the 0. But both of the 1 1, then it should be the 1. Both of the 1 1, then it should be the 1. Then same thing we had to be, this column we had to be find with the x and y operator with the considering and x, we can say that x and y are not the operator, x and y are the variable. Which is the operator? That is and is the operator, and that we had to be find with respect to this. And then we go for the or operator. So we know that or operator, any one of this will be the high getting values, then output should be the 1. So these all concepts we have getting with these values, that is along with your decimal calculations are there, different variables are there, and these particular variables we have to be find with along with your operators, such as and operator and the or operator. And this combinations we have done with respect to this uh, with the logical functions. Then we have to proceed for your next slide, that is a tautology and falsity. What is the tautology? Tautology and the falsity are there. That is, it is depends upon the output Boolean expression. Suppose the output Boolean expression is always a true, or it should be considered as a 1, then it is called as a tautology. And if the output of the Boolean expression is always false, or it is a 0, then it is called as the false. It is pronounced as a fallacy. As per your convenient or your pronunciation, you can go for this. But this is a very important thing whenever you have a Boolean expression, whenever you are considering all these particular data within your particular Boolean laws, within your Boolean theorem, within your Boolean concept, within your Boolean values, within your different Boolean variables. It is a very important whenever you are giving the particular condition as a true, condition as a false. Yeah, it may be considered as a 1 or the 0, respectively. Okay. Then
then we know that this is a tautology and falsity are the very importance are there. But how we can implement this, because implementation is very important, because we know that all the theoretical concept we have, all the functions we have, all the boolean values we have considering the different variables, that is two variable, one two variable, three variable, four variable, different variables are there. But how it will be completing, or how we can apply this particular for a computer electronic circuits. And this is a very simple, but having the proper crystal clear concept. These all the boolean operations are depends on your logic circuit, and these logic circuits are of the your logic gate. So already we have discussed in your first video, there are the different logic gates are there, that is the basic gates, universal gate, and the derived gate. But within your this particular within this video lecture, we have to be focused on the minimization technique, what are the different boolean laws, how the laws will be considered for your implementation, how the minimization techniques are there, so it can be considered. Okay, then we go further this, that is already we have gone through the logic gates. But here we will go for the what is a particular truth table. As we know that how the AND operator has been done, how the OR operator works, how the not operator, then it is a very easy it is a very easy part to understand the basic gates. Why we have learned the basic gates? Because within your boolean function, within your boolean operator, within your boolean logic, or the logic variables, these are very important parts, which is used for the minimization of all the techniques. So it's a very think you should, all students should know about it. That is, we can say that the logic gates are the operators which is hand one or more than the one input we have to be applied, but output should be the one, because the single output is only consideration or the basic characteristic of your gate which has been used for the either for the high voltage or for the low voltage. Then we go for the AND gate. That is the AND gate. We have an input. Already we have learned about the input A and input B. Then with this consideration, we know that how we can calculate the output as a and B. We know this is a particular things whenever we have the high value of input, and this particular high value of input will be reflect on your output. The both of your high, then it should be considered uh, then it should be consider as your output as a 1. Okay, then next we have seen this is a particular symbol of your AND gate, having the A and B as the input. We are operating as a and over there, and the output should be a into B. So this is your particular symbol of your AND gate. Then we go for the OR gate. Along with that OR gate, it is a symbol as a and B are your variable. Then OR is your particular operator, and it is assigned as a plus B. But not we can say that it is a plus B. It is a or B. Always keep in mind that it should be the it should be the A or B. When the output will be the A and B are should be the high, whenever any single input should be the high, then and then only the output should be the high. Okay, then we go for the NOT gate. Just you see the symbol of NOT gate, that is only one variable is there. Then we have go for the complement of this particular input, that is y is equal to a complement. And here bar indicate is the complement of values. When you suppose we are applying the 0, then it should be the 1. And suppose 1, uh, and suppose the 1, it should be the 0. Then we know we have the implementation idea, we have the different laws, we have the different boolean functions are there. So before the minimization of your techniques, before we are going for the k map, then boolean reduction technique, then kin max look quin max look see methods are there. So depends upon all this particular thing, you should go for the different properties are there. Their total, I think, there 1 to 10 properties are there, and these properties are very important. You every student should be gone through this all the properties. That is name as a properties. First name is the properties as a zero. That is zero with considering the any variable. It should be whenever you have a or operator, then it should be the A. But when you go for the AND operator, then 0 with respect to that particular variable, it should be the 0. Then we go for the properties of 1. That is 1, it is along with that particular variable, then output should be the 1. And when 1 is along with your operator, that is A, it should be the A. So these are very important properties whenever you are considering for the your Boolean function. Then we have a commutative law, then we have a associative law, then we have a distributive law. Just gone through this, all the commutative law, associative law, and distributive law are very important whenever you are finding the different theorems are there. So within this particular video, just we have learned about the theorem and the functions are there. But in your next level, we can go for the minimization technique. The best one more examples are, that is the De Morgan's theorem is very important. That De Morgan theorems always they are asking in your question paper, in your paper pattern they have asked this. Maybe this type of the Boolean algebra and Boolean laws they may ask, that is write down the different commutative law, like write down the associative law, what do you mean by the distributive law. So this type of the question they may ask in your exam also. Okay. The independence, or we can say that it is the identity law, and the absorption law, or we can say that the we can say that it's a redundance law. So with this all the properties, or with this all the particular functions we have going for this, it is very important when you go for the different theorems. Then we have a complementary law is there, involution law is there, and we go for the De Morgan's theorem law. So this particular De Morgan's theorem we will see in a next lecture, that is regarding how the De Morgan's theorems will be implemented, how this it is used for the implementation of your Boolean, how it can be used for the minimization of your different techniques are there. So that we will see in a next video or next lecture. So what we have seen in a lecture 1 and what we have seen in a lecture 2, we had to compare this particular data along with all the things. And you should aware about logic design, how to go for the implementation, what are the particular Boolean, what are the particular Boolean laws. These all terms you should know as an introductory part whenever you go for the minimization technique. So this is your second video lecture or second video series for you from your first unit, that is a minimization technique. In your first video, that is we have assigning as a logic digital electronics and the logic design. I have assigning the name over there. So within that we should go for the particular, that is the minimization technique. And it is very important when you go to see all the terms. So all students should be very best of your study. And it's a very great thing that is you are also accounting with all the video lectures, and every student should be gone through this. So all the best. Thank you.